So we talked about the weighted mean in the previous video, and you see that I don't have the weighted mean in this list, and I also don't have in this list the geometric mean, and I left those out of the list. They're in the textbook, and we're talking about them, we're learning about them, but for me, those are a little bit like, that's kind of nice to know at this point when you're learning about statistics. It's not really need to know the weighted mean. It's like, yeah, that's nice to know. You got it. You understood it in the last video. You understood weighted mean. But I didn't add it to this list because these are the ones I really want you to kind of like, okay, I've got those. And weighted mean, and particularly also geometric mean, which we're going to learn about in this video. Those are just kind of like, they're nice to know. They're not need to know. So I didn't put them here. You'll gain some exposure to them, a little bit of familiarity with them in the previous video. In this video, the previous video is the weighted mean. This video is the geometric mean. You're going to gain some familiarity with them, but once you have that familiarity, we're not going to deal with them for the rest of the course. And so, not needed for you to really be like, all right, I got to remember this. It's just like, just get a little exposure. It's not a big deal. And so we learned about the weighted mean. We talked about black beans and buying pounds of black beans at different prices in the previous video. In this video, we're going to learn about the geometric mean. And for the geometric mean, I have this image right here. Because the geometric mean really corresponds to something where you have like compounding growth over time. And so a lot of people haven't been exposed to how compounding growth works. It's a really important concept. It can make a huge difference in your life. But let's say right here I invest $100. After 1 year, I'll have earned some interest on that $100. The amount of interest that I earned would be like from the tip of my finger up to the top of the second column in this bar chart. That's the interest I earned after the first year. Well, now I have this much money on my bank account, and I'm going to earn interest all on this amount of money over the next year. And so I'm not only going to get interest on my original $100, but I'm also going to get interest on the money I made in the first year. And so over time, I'm going to make interest on the interest that I made, and that's going to compound. And so the next year it'll be this, and the next year it'll be this, and the next year it'll be this, and the next year it'll be this. And that's known as compounding growth, or it's also known as exponential growth, because it just keeps getting bigger and bigger and bigger. And so just to illustrate exponential growth, I'm going to do, and the reason I'm illustrating exponential growth is because the geometric mean allows us to find the average growth rate over time. So instead of adding up each of the individual growths every year and then just dividing by the total number of years to get a mean, which would be incorrect when you're dealing with compounding growth, because it's not taking into account that you're getting interest on your interest over time. Instead of doing that, you have to calculate with the geometric mean to find what is the mean, the average growth you got each year, taking into account that you're getting growth on top of your growth, interest on top of your interest every year. So the first step in this is just to kind of expose you to how things can compound over time and how you could continue to make more interest on your interest and how that just continues to grow, because that's a really good thing to see. So if these are my years here, and this is my, let's just do years 1, 2, 3, 4, 5, and we'll do that, and we'll take this out. And we'll do this all the way for like, I don't know, you're maybe in your late teens, early 20s. We'll do this all the way until, like, we'll do this for 40 years will take you to 58. 45 will take you to like 63 if you're 18. So we'll do this for 45 years. And then let's say that, we'll insert one more row here, insert a row above, and we'll do a 0. And let's say in year 1, we start out with, let's say every day, let's do this, every day we put in $5. And so $5 every day, and if we're doing this every day, now let's $5 every day would be, $5 every day is going to be equal to 5 times 365. And we'll put one up here above it. I'm just thinking this through as I go. We'll put another one above it. And daily amount invested. So instead of Starbucks, going to Starbucks every day, let's say each day we put in $5. And so this is going to be equal to beginning of the year. So we'll put here, we'll do here, beginning of year. And so the beginning of the year, and we'll just put all this in at the beginning of the year to keep it simple. There's 365 days in a year times this amount right here. So beginning of the year, we're putting in that much. That's the amount we would have spent on Starbucks over the year, going to Starbucks every day. But instead, we're going to, at the beginning of the year, put that entire amount in our bank account and not touch it. And then the interest, we'll put in here. We'll create one more row. Boom. And we're going to invest this. We're going to invest this in, so our interest rate will be 0.1, so 10% a year. And so what is the annual return of the S&P 500? Annual return of the S&P 500 over the last 20 years. There we go. We'll do that one. So over the last 20 years, it's been 11.1%. The S&P has returned 11.1%. So that's 10%. Here's 11.1%. That's what it returns every year. So interest earned will be equal to this amount times that amount. So we earn this much interest. And amount at end of year, and the amount at end of year is going to be equal to this amount here plus that amount. There we go. And amount at beginning of the year. Amount at beginning of the year is going to be this amount plus amount at end of the year, this amount plus, and then we'll do 365, and we'll do times that right there, and we're going to hold that constant because every year we're putting in $5, right? Every day for the entire year, 365 days, and then we're adding that to what we already have in our bank account. And so we're going to put that there. So there's our amount at the beginning of the year. And now we could copy this down, Control C, Control V, and let's just see, oh, because I didn't hold the interest rate constant, which is at FC2, so I'm going to hold that constant and now copy this down. And so this year we made $427 in interest. And now when we add this together, that one plus this one, boom, we have $4,280. And I'm just going to format all of these as dollars. So I'll come up here and click make that money. So there's the money. I don't know if I like the money on it. I guess it's fine. And now I'm going to copy this and bring it to the next row and just check my formulas to make sure they're right. So this one, I got the D6. That's the amount I had at the end of the year. And then I add to that 365 times my $5 that I put in each year, every day, right? So that's, however much I put in. And then interest I get that year is this much. And now this is the amount at the end of the year. I'm going to copy this, and I'm going to do this all of my life. So I'm going to come down here. Oh, that's too far. I'm going to come down here and do this for all of my life. Till I'm like, if I'm 20 right now, I'm going to do it till I'm 65. And by the time I'm 65, as opposed to buying Starbucks every day for $5, if I invest $5 every day of my life, by the time I'm 65, I'll have $2.3 million. And if I do this for another, let's just do this down here and drag it like this and check to make sure it works. If I do this for like 60 years until I'm 80, so 60 years would be 2 more. If I do this until I'm 80, and you could really see the power of compound growth here. Man, we went from 9 million to 11 million in 2 years. And if I just do this all of my life until I die, right, and I do it and I live till like 95, I'll have $54 million. $54 million just putting in $5 a day. And if I leave this as a legacy for my grandkids, and I do it for, like, we do this as a family, $5 a day, do this as a family, and we do it for 125 years as a family, $5 a day for 125 years. So I'm not going to see that wealth. My kids won't see that wealth. But, we did it for 125 years, 62 and a half years for my life and 62 and a half years for my kids' life. 125 years, we'll have $10,510,530,110 and that will be not my kids, that'll be my grandkids. We'll have $10 billion. No joke. And it just, we went from 3 billion to 10 billion in like 15 years. Like, you just can't touch it. It's $5 a day. That's the power of compound growth, which is extraordinary. And most people don't understand that power. Like if my parents had started this when they were young, like if my parents had started this in like, you know, like let's say my dad started doing this in 1940. Well, he's born in 39. So let's say he started doing this in 1950 when he was 10. So 1950 to today is 74 years. 74 years, my family would have $48 million right now, almost $49 million. Wow. It's hard not to spend it. It's hard not to say, let's get that new car. It's hard not to say, let's get that nice house. And that's what sinks most people. So this is compound growth. And we use the geometric mean to find out the average annual return of this growth, because that could change over time. The interest rate every year is the same, but we're making interest on interest, so it's compounding. And so here we have the geometric mean calculation. And so we have a new symbol here, and this symbol might seem a little strange to you. So what I did is I went to the snipping tool, and in the snipping tool, you click it, and then you could take a picture of something. So I click New Snip, and I take a picture of this thing, boom, right here like that, take a picture of it, and then I save this to my desktop. I saved it to my desktop, and I came here to ChatGPT, and I don't want that because I already did it. I came here to ChatGPT, and I uploaded that image, and I said, please, and you upload the image just by clicking this attach file right here and choose Upload from Computer. I said, please explain all the symbols, Greek letters, and everything in this image. And it says, let's break down the formula for the geometric mean shown in the image. And so here, you know, it's breaking it down. The formulas for calculating the geometric mean of a set of numbers. N, we already know small n means all of the items, represents the number of data points in the set, right? So here's n, number of data points in the set. It's the total count of values you're calculating the geometric mean for. And here's pi. This is the symbol for pi. Those two bars look like Greek columns. It's pi. This is the product operator. So just like we saw sigma is for summation, this pi symbol is for, you know, multiply everything together, which indicates that you multiply a series of numbers together. It's similar to the summation symbol, but for multiplication. So here we're going from I equals 1 to n, and we're multiplying each data xi together. Cool. Now all we have to figure out is this 1 over n thing here. But we can see this here. This is the part of the formula that tells you to multiply all the values together, x1, x2, all the way up through xn. And so that's interesting notation to get used to right here. The ... xn would be the last number in the element, the data set. And 1 over n indicates that you take the nth root, like the square root, the second root, or the third root, or the fourth root of the product of the values. The nth root is what makes this the geometric mean, as opposed to simply multiplying the values together. So the full explanation, the geometric mean is calculated by multiplying all the numbers in a data set together and then taking the nth root, where n is the number of data points. This means this mean is especially useful when dealing with data that involves products, percentages, or growth rates, right? For example, if you have a data set with 3 values, x1, 2, and 3, the geometric mean would be x1 times x2 times x3 to the square root of 3, right? And with larger data sets with n values, we would multiply all n values together and then take the nth root. That's the geometric mean, and we also have the geometric mean explained up here. So let me just find that wherever it is. Hold on one second. I'm going to pause the video. I'll be right back. All right, so part of what I hope you're learning in this class is the power of using ChatGPT to help you learn. My job is to not only teach you, to not only give you a fish, right? It's, you know, there's an old saying that says, it's better to, instead of giving a person a fish, why don't you teach them to fish? If you give them a fish, you only feed them for a day, but if you teach them to fish, you feed them for their life. So that's part of what I'm doing here with ChatGPT is I want to show you how to use ChatGPT to help you learn so that you're empowered to learn whatever you want to learn. And that's why I'm leaning on this, because it's the newest, greatest tool. It's like having a friend who's a genius who's willing to sit there and talk to you for as long as you want to talk and give you examples and explain things to you. And so hopefully that's really empowering you to be a lifelong learner and to really figure things out starting right now, starting today. So that said, I said to ChatGPT, can you please also give me an example of using the geometric mean? And so here's the scenario. You're evaluating the average growth rate of an investment over 3 years with the following annual growth rates. You got 10% the first year, 5% the second year, 15% the third year. The geometric mean calculation is calculated by multiplying all the numbers together and then taking the nth root, where n is the number of values. So here's the formula. We know that. Step-by-step calculation, multiply all of the growth rates together, you get this. And then the geometric mean is you take that, the third root of that, and you get this. So that means that on average, the mean, you got 9.75% growth every year, right? Like that's the mean growth rate, geometric mean growth rate. Why use? So the geometric mean growth rate over 3 years is approximately 9.75% per year. And why use geometric mean? The geometric mean is especially useful in cases like this because it accounts for the compounding effect of growth rates. So that's what we just talked about. So you could pause the video here and you could read a little bit more of the explanation. But just the simple mean, right? If we were to find the mean of these three rates, 10%, 5%, 15%, that would be 30% divided by 3 would be 10%, right? That would be the simple mean, 10%. But the compounding annual growth rate is 9.75% over all 3 years because you have that compounding factor. So that's what the geometric mean is. That's the kind of situation in which it's used. It's good to know about, and it's super good to know about the compounding growth rate of interest and how you should start investing $5 a day and do that for 2 family generations, and then your family will have plenty of wealth. All right, so that's the geometric mean.